Start. Okay. Hello, everyone. I'm Sagie, presenting with Eran Gampel from Toga Networks, Huawei. And we are going to present a topic that's called running Neutron at scale. I'm personally very excited to be presenting this year. For the last year, we've been presenting this all over the world, so it's great to finally do this in an official Israeli event. Let's get started. So why are we talking about Neutron and scale? For the past year and a half, both of us were dealing with this issue. We got a requirement from Huawei, and Huawei has a very big public cloud offering. It also has a very big private clouds offering. And when I'm talking about big, we're talking about thousands of servers. And the feedback that we received from Huawei is that networking and OpenStack doesn't scale in these numbers, okay? They were hitting a lot of challenges and limits. And the interesting thing about it is that during this year, we met more companies and more people, and we keep hearing the same things over and over again. And we decided to try and solve the problem in a bit different way. So if you're familiar with Neutron reference implementation, this is how it looks like. I'll not go over how everything works, but the one thing that you immediately notice is that there are so many logical elements out there that are being used to implement networking. And this is logical elements. This is without the actual physical networking devices. And all of these elements, you can see here, you have the layer 2 agents, the layer 3 agents sitting at each compute node. We have the DHCP namespace, the metadata proxy, the metadata agents. And all of these agents are communicating with an unoptimized RPC bus that is carrying a lot of information that it's not supposed to be transferring. If you know how layer 3 is implemented with namespaces and the overhead they bring, and even today, security groups, whether you know it or not, every VM or every port in your system, there is a Linux bridge that is created when this VM is created to implement security groups using IP tables. And what we are trying to look at Dragonflow is take this model, take the functionality that Neutron brings and simplify it. So what we are trying to do is turn this, basically, into this, okay? We are trying to get rid of all of these unneeded elements, gain the same functionality. And I think the nice thing about this that we are trying to create is create this very optimized infrastructure. We have a distributed SDN controller sitting at each of our compute nodes. And we have this infrastructure which is providing us redundancy and high availability. It is optimized for syncing network policy and topology across all the nodes in our setup. It is optimized to notify on configuration and policy changes. And now we don't have to worry about every time we want a new network service or a new feature. We have this infrastructure already done, and it let us focus and implement networking services very, very simply and very, very fast. So Dragonflow is a fully open source project. There's no hiding parts anywhere. It's an official OpenStack project, part of OpenStack Big Tent, starting from Mitaka. And the thing I'm personally very proud about is that we actually, in the last month, gathered a pretty nice community around Dragonflow. It is being deployed, of course, in Huawei internally, but we also have a very big startup company in China that is actively contributing to the project, and they are backed by Intel and partner with Rackspace, and their network architect is one of our core team. We have the second biggest hosting company in Europe that is lending us infrastructure and servers to test and deploy Dragonflow. and they're also looking at actively using it and contributing. In the hosting summit, we met with many operators. One of them is actually presented here earlier, and they are also looking at using Dragonflow for various use cases. So we are very happy about this adoption, and we are happy that users and companies are starting to see the advantage and the simplicity of Dragonflow and how it can address their use cases. Another thing that is important to note, we recently conducted some testing, some performance and scale testing, and I'll not go over too much over it, but if you want, you can come talk with me later. We received some very surprising results. We are now hitting around 30 to even 100% improvement on the data path, depending on the traffic types and patterns. And the more important thing is we are seeing very good control plane results. We are being able to scale to thousands of compute nodes with around 50 to 100 ports in each of them, which are pretty good numbers. And I'll hand over to Eran now to go a little bit deeper into the technology behind it.
Hi, everyone. Thank you, Gal. We'll start with a high-level overview of Dragonflow architecture. When we start looking about the scale problem that we have in the networking in Neutron, we found that the way to transfer the data into the compute node is one of the bottlenecks that blocks us from really high scale. So the first thing we did is to try to figure out how to do it, and what we are doing is we have the SQL database in Dragonflow, in the Neutron core plugin. We transfer all the data into a key value, and we have a NoSQL key value database. It's a pluggable interface. You can use any existing solution. It's a very simple interface. And then in the compute node themselves, you have a DB agent that knows to read these key values. And inside Dragonflow agent that we have on the compute node, we convert them into a JSON object, and then the local controller can use them. What we gain by that is allowing to use existing solution, and we'll go over it in a minute, like Cassandra, Zookeeper, etcd, RefInkDB, RamCloud, depending on your SLA and your needs, your scale, SLA, latency, etc. And by not compiling the logical flows in a centralized place, but passing the policy level abstraction into the compute node, it allows us to push smartness into the edge. And we'll show in a minute a few examples of smart application that we can do relatively easy on each compute node when it's just need to compute 100 ports or 200 ports, and that doesn't need to compute like thousands of ports. So if we deep dive a little bit lower into the architecture, we see the green parts. The green parts are the parts that belongs to Dragonflow, sorry. And below we have the OVS. It's a plain vanilla OVS. We interact with the OVS via OVS-DB to configure the ports, tunneling, any port configuration, and OpenFlow in order to configure the flows. On top, we have a Dragonflow core plugin. We are in the process to moving to ML2. I will go into it a little bit later. And we support DB driver currently in the Mitaka. We support Redis, etcd, Zookeeper, and other databases. You need to choose one, of course. And we support PubSub driver. PubSub is, I will go into it a little bit later. We need PubSub for a database that don't have monitor capabilities and notification capabilities, or if the database like etcd or Cassandra or any other doesn't provide good SLA, good performance for its monitor, then you could use PubSub to notify about changes. Inside the compute node, you can see that we have the pluggable DB layer that convert key value into objects. And you choose, of course, one database. We have the southbound database that could be, in this case, and what we support now is OVS-DB to configure the tunneling. But we have planned for the future to support Smart NIC and to allow tunneling offloads by this southbound interface. And inside the Dragonflow controller is actually an infrastructure to load application dynamically. We currently support L2, L3, security group by floor, distributed DNAT. We are working on distributed metadata. But if you want to develop your own application, this is an infrastructure that you won't have to deal with high availability, with how the data comes to you. You just need to write the application. And we'll show a few examples how easy it was, relatively easy to do that. What do we support for Mitaka? So for Mitaka, we support all the tunneling, STT, VXLAN, Geneve. All of them are supported. Distributed L3, we support actually two flavors, one that is full proactive and one that has some reactiveness in it. Distributed DHCP, we support this DHCP suppression in the compute node, meaning any DHCP traffic doesn't leave the node. We have a local agent that knows to answer, and we'll show why it was easy to do it in this kind of architecture. We support etcd, Refink, RamCloud, Redis, and Zookeeper. For the pub sub, we support the 0MQ and Redis. Security group is all down in flows. And this, as Gal said, a big part of the performance improvement was by doing that, the control path and the data path by removing, I don't know if all of you are familiar, but before that, for security group, there was a special Linux bridge below the port and IP tables rules on that port. And selective database distribution is actually the feature that allows us to scale to thousands of nodes. And it means that you don't need to distribute all the data to the compute node. You just distribute whatever this node needs. So if, for instance, I have VMs only from tenant A on compute node X, I don't need to transfer information about tenant B or into that compute node. And we'll show a little bit about it in a second. So why did we choose a pluggable database, and why did we didn't implement one, or why we don't use the message queue? So first of all, the requirements are that you need from that kind of a bus is HA, scalability, and different environment has different SLA. So one environment, latency will be very important to it, and then they can use RamCloud that provide microsecond latency. And they need to pay by cores on the compute node. A different solution needs to scale really big, so it will use a different solution. We found out there's more than few solution out there. It takes few years to make something like that into a product. And the most important thing, it allows us to focus on the virtual services in the overlay themselves, and that's what allows us in relatively low time to gain a lot of features. About the database distribution. So this is a full distribution, meaning if I have a tenant coming to the northbound API of the CMS, creating a virtual router, and another tenant coming, creating another virtual router or port, this data will be distributed to all the nodes. But then when we wanted to scale, we understood that if we use a subscription and we do it now by the tenant, but the mechanism allow topics of subscription that can be modified later to even inner topology inside the tenant overlay. So currently, when a VM comes up, a new VM of a tenant in a compute node, we actually understand that this compute node, the infrastructure, that it doesn't have the information about this tenant. It goes fetch all the information about the tenant and subscribe using the pub sub on the topic of the tenant, and it will get all the information. That's what one of the key elements that allow us to scale into 1,000 of nodes that I will show in a minute. The Pub Sub solution, I won't talk about it more, that we support multiple publishers from the multiple Neutron servers into multiple subscribers that can reach thousands of subscribers below. Distributed DHCP. So distributed DHCP is a nice use case to show the difference in the architecture and what Dragonflow architecture allows. So the current reference implementation use DNS masquerade process per DHCP server in a virtual L2 network. And so, for instance, if you have 100 tenants, each one with 3 virtual network, you need 300 DNS masquerade processes with a namespace around them in the network node. And if you want high availability, you need even more. In Dragonflow, because we have all the knowledge about the topology inside the local cache of the controller, we actually did the DHCP suppression. We enter reactive flow to go to the controller. The controller read the data from the database, put it into a DHCP options, and move back to the VM. And we could do that because we have all the data, all the policy level abstraction, we have them below. One advantage of doing it this way, we can have the list very short. So currently in the Neutron reference implementation, the list is almost a day, because if not, you have a lot of DHCP traffic going on the network. In Dragonflow, the list is few minutes, I think it's 5 minutes. So you can even lower it because it's only local traffic. The roadmap, and this is very important, our roadmap to the scalability is very challenging. We want to reach 10,000 nodes. We don't know when we'll reach that. Current test, we are around 3,000 using, in this case, Dragonflow and Redis. Redis as the pub sub and Redis as the database. We hope for the next phase to reach 4,000 and then to reach 10,000 in the end, but we have a lot of work yet to get there. The current feature from Mitaka, I cover some of them. We have new application coming. We're going to support hierarchical port binding, container support, SFC, and we hope to have the topology service injection and optimize for scale and performance. Just to talk briefly about the hierarchical port binding and why are we moving to ML2, one of the requirements we got is to interact with the underlay. And one of the options to do it is once we support VLAN in the VLAN networking and support hierarchical port binding, other solution like ODL or any other SDN controller can control the underlay, and we will control the overlay and provide the network services themselves. Neutron released the application that we are planning. All the specs are out there. IGMP application is very interesting. IGMP is providing most solution today in the cloud. When you talk virtual and multicast, they actually make it into a broadcast in the end. So we will know only which compute node are registered on the multicast for a tenant. Distributed load balancing, we are planning only the east-west in this release. Distributed metadata proxy, we actually have the code and spec out there, so it's a very good stage. Port fault detection is another application, DNS service. I don't know if we'll get all of them. It depends on the community and how many people we get to join us. Now I will let Gal talk about containers.
So who here knows what is this blue thing riding on Dragonflow? Anyone? Okay. So this blue thing is an icon of Project Courier. It's another OpenStack project. The mission of Project Courier is to bridge the gap between networking worlds of containers with OpenStack. Essentially, it says if you like to run your containers with Kubernetes, if you like to run it with Docker, Swarm, or with Mesos, and they have their networking models, what Courier does is give you a seamless integration with OpenStack networking. So you can use all of OpenStack richness and flexibility and advanced networking services with your container environment, and also link them, connect containers, connect VMs, connect bare metal, all with the same networking model. And as we are deeply invested in Courier, as I'm also leading this project, we are working very hard on Dragonflow to support Courier and address special use cases in containers networking, nested containers, and so on. I don't have enough time to go over all the use cases, but feel free to come and ask me later. In terms of networking services, so one thing that I mentioned at the start is that we want to keep Dragonflow simple, okay? We don't want a lot of code, but still there are so many use cases, so many operators, so many people that want different kind of networking services. And for this, we invented a very nice model that we call the service topology injection. It lets you add networking services without actually changing Dragonflow code. And I have a blog post about it and some videos from presentation in Austin. You are invited to look. We are also looking at supporting classical service chaining and things in that area. So, as I mentioned at the start, we started Dragonflow as a community project, okay? It's not something that we build for Huawei alone. It's something that we want to gather more use cases, more companies come and join us. We are trying to do everything from the requirement definition, the designs, the specs. We have a weekly IRC meeting. And I would like to invite all of you that are thinking and wants to hear more, or wants to use Dragonflow or even contribute, come and talk with us and join this effort. Thank you. We have like 3 minutes for question, if anyone has any. Yes. There's nothing concrete yet, but we believe that the model that we define will make it very easy to integrate with bare metal. Again, depends what kind of workloads you're running in the bare metal. For example, if you're running containers, then this is already applicable with Courier, for example. No. Also, if you have your bare metal Kubernetes cluster, for example, you can right now integrate this with OpenStack workloads. So you can take your containers, connect them to VMs in the same network, same router, and so on. We don't have anything concrete, but if it's something that you're interested, we can speak about it.
Yeah, please, you can register a blueprint and come to one of the IRC. And if there's a need and willingness from someone to take this effort, we can do it as a community. But it's something we start thinking about it, but not for this release, for next release.
So migration is something that we are, it's of course migration, deployment, packaging, and things like that are things that are very interesting to us, especially now that internally in Huawei they're adopting this and deploying something like this and migrating from environments, already existing environments to Dragonflow is important. I believe that the model right now, the move to ML2 and the model that we have this database which holds all our information will make this process relatively easy. But we started right now at thinking about how to do the migration and how to do packaging and deployment, but it's not there yet.
And we did a lot of work for DB consistency between the We did a lot of work about the DB consistency between the SQL, NoSQL, and the cache. So we have version per object and a lot of infrastructure work that could help us in those migrations.
Yes, what Eran is talking about, there is currently a serious problem when you have a Neutron implementation, a Neutron solution, how to keep database consistency between the Neutron database and your SDN controller or SDN solution, and if you have another database from the SDN solution, so how to do reliable data synchronization and things like that, that when you run this in production, you're facing with, and we have nice solutions for this in Dragonflow.
How do you compare yourself to the
So this is a good question. I can answer it. I'm actually I was there from the start in OVN. And I think that we see some of the features that you see here are features that we tried to push to OVN. And we see a few key differences between Dragonflow and OVN that led us to start the project. The first one is the distributed database. Okay, we think the database, if you know OVN, it uses OVSDB. Okay, it's not pluggable, you have to use it. And OVSDB is currently, it doesn't support redundancy, it doesn't support high availability of the database. We thought the database layer is a very critical point in scale and performance, and when you start to think about the features that you need from this, when you start thinking about security and defining ACLs on the database, and all of this, we decided to take, I think, the simple route and do pluggable, so you can use production-grade products that are already optimized and working perfectly for this mission. Another very important point is the information that we distribute to the edge. We distribute policy-level abstraction, OVN distribute logical flows. This lets us first distribute reduce data, do a lot of nice tricks about how we distribute to which compute node. And it also lets us, as Eran mentioned, to do a very nice integration with smart NICs and hardware offload. So the edge controller can take this policy and translate it depending on the hardware capabilities in the node. So it's something a little bit harder when you get already processed flows in the edge. And we have a lot of other small differences that led us to start the project from the model and the database. And our requirement was to get into production pretty quickly, and we just didn't feel that OVN will meet our requirements. Let's talk about it offline because we're out of time, sorry. So, thank you everyone.